especially point number, because when we do the control limits from the resulting control charts, sample number 2 and 4, they were not, that is sample number 2, which has got the fraction defective as 0.109, and the allowable maximum, the upper control limit is 0.10. So it was falling out of control limit. Okay, and the sample number 4, 0.114, it was falling out of control limits of not meeting the upper control limit. And one more thing, the 19th observation, if you look at it, that is what I mentioned about it, 0.038. But the lower control limit for this P chart being 0.044. Lower control limit, that means it was much below that. This is the one thing you need to understand, because the lower control limit, that means I will just mention upper control limit for P chart, it was found to be 0.1019. Central line, it was calculated to be 0.073, and the lower control, it was calculated to be 0.0. So out of 19 points, 3 points, namely sample number 2, sample number 4, and sample number 19, were found to be out of control limits. Sample number 2 and 4, sample number 2 being 0.109, okay, but this one, the upper control limit being 0.1019, that was falling out of control limit. Sample number 4, its fraction defective was 0.114, which is again more than this. And the third point, that is 19, sample number 19, its fraction defective was calculated to be 0.038, which is lesser than this, but it also fell outside the control limits for not meeting the lower control limit. Actually, we expected, because why this observation is to be made is, we expected that the quality limits or the specification limits are these two. But what I am getting is, it is much better than this. Fraction defective is less, is it not? That you try to find out. Try to think about that. Fraction defective is less than the expected one. That means it is better. Now again, why the process is to be stopped and the investigation is to be made. So that should trigger your mind. Okay? Actually, I wanted it to be 0.044, but I am producing more. And why the process should be stopped? We should be happy about it. What could be the reason? Okay, yeah. The reason could be we are producing more than required. So we might be incurring the additional cost. go for the wrong. Okay, next numerical I will take up, because these numericals I am taking up in a particular way. Okay, just take down this example. An item is made in lots of 200 each. The lots are given 100% inspection. The record sheet for the first 25 lots inspected showed that a total of 75 items were defective. A. Determine the trial control limits for NP chart or instead of that, determine the trial control limits for appropriate control chart. B. Assume that all the points fall within the control limits. What is your estimate of the process average fraction defective P prime? C. If this P prime remains unchanged, what is the probability that the 26th lot will contain exactly 7 defectives? Or 2, again in that one itself, that it will contain 7 or more defectives. Okay. Have you understood this one? Okay. Let us see what are the given things first. Because we need to analyze the problem. What are the given things? That is, analysis of the problem means what are the given things and what things have asked. And next, for the things to be calculated, which equations are to be used. So that we'll get the proper solution for that. So now first we'll write the given things. Okay. First one is, how many samples are there? For that purpose, it directly doesn't answer the same thing. It says in a lot. Because the lot, that means the lot is always denoted by number n. Lot size, it is denoted by capital N. That is 200. Is it right? Is it right? That we need to understand. Because lot size, that means it is 200. The item is made of lots of 200 each. The lots are given 100% inspection. There is no question of taking the sample out of this one. This itself will become now the sample size because it is given 100% inspection. Try to understand. Okay? The lot size itself will become the sample size, because don't get confused with that one, because usually lot we will represent it by capital N and the sample size N. So in this case 100% inspection is given, then N itself, small n itself will become the sample size 200. Likewise, how many of these things were inspected? 25 lakh lots. That means total number of the items inspected will be, total number of items inspected will be equal to 200 into 25, because 25 lots have been inspected. So totally 5,000 items were inspected. Okay? And he says the record sheets for the first 25 lots inspected showed that a total of 75 items were defective. 75 items were total number of defective items is equal to 75. This is also, it is given. Determine the trial control limits for the appropriate control chart showing the number of defectives in each lot. That means it should tell us, because here itself he has said showing the number of defective items in the lot. That means the control chart for defective is to be used. So that means either it may boil down to P chart or NP chart. There is no question about C chart or U chart. It has to be either P chart or NP chart. Now, we can use NP chart because the number is remaining constant. The lot size is remaining constant, 200. Not 200, 220, or unlike the previous example, it is fixed, 200 only. That means sample size will always remain fixed, 200. Try to understand here the sample size is also more. That is what I was telling when we were discussing, when we were comparing between the control chart for variables and control chart for attributes. We were discussing that the sample size for the control chart for attribute will be more. That is what the practical things also it will tell us. Okay. Now what he wants us to find out? Determine the trial control limits for the appropriate control chart. Now I have identified the appropriate control chart is going to be NP chart for the reason that the sample size remains fixed. The sample size is 200. So that means what we need to find out, these are having given these things. These are the given things. What has been asked? We have to find out the upper control limit for NP chart, central line for NP chart, and the lower control limit for NP chart. Try to understand, even if you calculate, even if you use the P chart, there is no harm. It can be considered correctly. But when he says appropriately, naturally, the NP, this one, it carries more weightage. It doesn't mean that P should not be used. Yes? P chart can be used, there is nothing wrong in it. But if you use C chart or U chart, no, it is completely wrong. Okay, that needs to be understood. Because P chart is a universal chart in lieu of NP chart. Either P or NP, if you have a doubt, go for P. Don't bother about it. Okay, is it understood? But definitely not C and U chart for this one. If you calculate C and U chart, this thing control limit, then that is totally wrong. Okay. In any case, for both P and NP chart, we need to calculate P bar. That is why he has asked about the process average or whatever it is in the subsequent, the B part or whatever it is. That is, first one is, that means you need to find out these things. To find out second, what he says, assume that all the points fall within the control limits. That is what you need to understand. When all the points they fall within the control limits, then only you are going to find out that process average. The same thing we followed in case of control charts for variables. For finding out sigma prime, the first and necessary condition was that all the points should fall within the control limits. The same thing here. We can find out that P prime only when we establish that all the points have fallen within the control limits. So they have calculated for all these 25 lots, okay, the control limits, and when they have compared, all the points have fallen within the control limits. Hence, he is asking, what is your estimate of the process average fraction defective? That means we need to find out what is P bar or P prime, whatever it is. That is what we say. Line itself, that is what we can find out. Or here he says, what is your estimate of the process average fraction defective? He says P bar you have to find out. NP bar means multiplied by this 200. Okay, that is process average, but specifically he wants you to find out the process average fraction defective. Okay. Now, here central line for NP, this thing, it will give you the average number of defective items. But what he wants, what he has asked, the average process average fraction defective. Okay. Next, see. If this P prime remains unchanged, what is the probability that, okay, if this P remains unchanged, what is the probability that the 26th lot will contain exactly 7 defective? That means again he wants you to find out what is the probability that X will contain 7 defectives, P of that one, or P is X is greater than or equal to 7, how much? These are the things to be found. Okay, got this one? Okay. Okay, now how to go about? These are the things to be found out. Because compared to the previous example, because earlier we were using then in that example, we calculated P chart. And of course, instead of calculating the individual control limits for each sample, we had used the average sample size there. Almost like this. Okay. Now it is NP chart. In addition to that one, what is the probability that it contains 7 defective or more? That is what the question is asked. Okay, my dear friends, now it becomes very simple. That means P prime, how we are find out P bar or P prime, both are same. Okay, don't get confused with that. That means 75 out of divided by 25 into 200. So this works out to be how much? This works out to be 0.015. P bar is 0.015. This is the process average. And it answers the B part as well. That is, if all the points fall within the control limits, then the estimate of process average fraction defective is P prime, that is equal to 0.015. Okay. Now, control limits. Central line of NP, this is N is 200 into 0.015. Okay. This is what is going to happen. So this is 200 into 0.015. This is, it works out to be NP bar is equal to how much? This works out to be 3. Lower control limit, this one, this plus. What are the control limits? In general, I am going to write this one. And then I will substitute by the particular this one. NP bar plus 3 sigma is under root N P bar Q bar. Okay, this is NP bar minus 3 NP bar Q bar. Okay. So now P bar is equal to 0.015 and Q bar is 1 minus 0.015. So I just substitute the values, all the values, 200 into 0.015 into 3, 200 into 0.015, 1 minus 0.015. This one is, central line is 200 into 0.15 and this one is 200 into 0.15. This is plus, and here it is minus 3 sigma limit. 200 into 0.015, 1 minus 0.015. So if you calculate these values, they work out to be upper control limit, it works out to be 8.1570. 8.1570. And central line is going to be 3. And this works out to be 0 because it works out to be negative. That means this NP bar 1 minus P bar under root multiplied by 3, it works out to be 5.170, hence it works out to be negative. So we consider this one is equal to 0. So upper control limit is 8.1570. What does it mean? It should not consist of more than 8 defectives. 8.15 we cannot find. Don't round it off to next. Even if it were 8.5 or 8.6, still we would have considered 8 defectives. What this one? That is most important. Don't again consider it to be 9. No. Okay? That means modulus itself is to be considered there. That is 8. Maximum number of defectives, when I take a sample of 200, it should not contain more than 8 defectives. If it contains less than 8 defectives, it will be accepted. What this one? The lot itself will be accepted. If it contains more than that, it will be rejected. Obviously, it cannot contain lesser than 0 defective. That is what it means. Okay, negative defective doesn't have any meaning. So that is why intelligently these things have been woven. That again you can see here that he has asked 7 and greater than or equal to 7. How intelligently these things have been asked, you just try to understand. That means maximum it can contain up to 8 defectives as well. Nearer value he has taken. Okay. What is that? Because that is almost touching that one. So if it is nearer to that, other side of the central line of 3, it is more dangerous, is it? That is why he asked like that. But on an average, it should contain 3 defectives. Average. Some maybe 3, 2, 1, 0, like that. Random. That is what these are the control limits, because we have answered the A part, these are the control limits, and I gave you the explanation for that. And if all of them they contain the defective less than or equal to 8, then the process average we can find out, that is process average P bar in fraction defective is 0.015. We have answered 2 parts. Now what about the third part now? That is, if the P prime or the P bar remains unchanged, what is the probability that the 26th lot will contain exactly 7 defectives? That it will contain 7 or more defectives. How to find out these things? Well, that is why, probably that could be the reason why I have taken up this problem, and maybe in my first class of this attributes, I gave the brief introduction about the probability distributions. So it will become more handy over here. Now if we look at it, it follows the binomial distribution. So one way is exactly, if we want to calculate, we can make use of the binomial distribution. That means in general, the binomial distribution for finding out the probabilities, it will look like this. Probability that x will take a particular value x is given by n cx into p to the power x into q to the power n minus x, where n is the sample size, x is the fraction defective number of defectives, whatever it is we are interested, and the q is the same thing, n, this one is n minus x. Okay, try to understand these things. Now here n is equal to how much? 200. I wanted for p that x will take the exact value 7. That is, n is 200, c 7, p is 0.015 to the power 7, q is 1 minus 0.015, that works out to be 0.985 to the power 200 minus 7, that is 193. Okay, you need to calculate like this. So of course with the computer you can calculate, no problem about it. Okay? And now this one you can calculate easily, there is no problem at all. But how to calculate probability that x is greater than or equal to particular value x? In this case, probability that the x is greater than or equal to 7. How do you find? Greater than or equal to mean probability that it contains 7 defective, probability that it contains 8, probability that 9, 10, 11, 12, up to what? We can go up to 200. Try to think. That means so many how. Then how much time it will take you. Try to think about it. So this one we can convert it to some complementary events. That is what we say. Okay. That means here what I will do. Two things basically, try to observe. Two ways I can make it. One is probability that it is x is greater than or equal to 0. Am I right? Greater than or equal to 0. Okay, this one, it will lie between 0 and less than or equal to 7. That means it is going to be 6 because it cannot take the fractional values. Okay. The another one is plus probability that x is greater than or equal to 7, less than or equal to 200. This is what I can put it in these two things. What I am interested in finding out this. X will take the value greater than or equal to 7. This one is exactly 7. That is what we are going to find out. So, but it also means that this one, the probability is going to be 1. This is what I am talking about, complementary even. Try to see here. Now, that means this can be found. This will be equal to what? Or I can simply say x is greater than or equal to 7 probability. This one I can say this is exactly equal to, that means this is probability that x is less than or equal to 6 plus probability that x is greater than or equal to 7 is equal to 7. This is equal to 1. Or probability that x is greater than or equal to 7 should be equal to 1 minus of this. 1 minus p of x is less than or equal to 6. Which is easier to find out? Because I can find out only 6 probabilities. Otherwise, I have to find out how many? 193, like this one. So it becomes difficult. In that case, we go for complementary. This is what I have taken. Only 7. That means now I have found out exactly 7. Likewise, exactly 0, exactly 1, exactly 2, exactly 3, exactly 4, exactly 5, and exactly 6 have to be found out. And from 1, it is to be subtracted. So we are going to left with this. What this one? Then you might start thinking of the other things. Do you remember, I told you, certain approximations can be done. Instead of going for this one, maybe we might be losing the accuracy to a very small extent. So I said, binomial distribution can be approximated by Poisson's distribution. What is this one? Poisson's distribution. Binomial distribution can be approximated by Poisson's distribution when the p tends to 0 and n tends to infinity. And I also told you that if p tends to 0 means if it is less than 0.1, it is 0.015 p. And n we said it is tends to infinity more than 50 because n is 200. And there the multiplication, that is both n and p, their value is, it is a finite. In this case, it is going to be 3. That means perfectly it can be approximated by the Poisson distribution. We need not have to calculate, go around about this one. I can give you the values, no doubt about it. For example, P of 0, it works out to be 0.0486. So this one, you got this one? Okay. This is equal to 1 minus P of 0 plus P of 1 plus P of 2, P of 6. This is what it means. Now this one, 1 minus P of 0, I said 0.04. If you calculate by this way, it gives you 0.486. One, it gives 0.148. Three, 1.148. Two, 0.2245. Like that. It goes on. P3, because I'll just wipe out this one so that you can be sure you can calculate this one. That means 1 minus 0.0486 plus 0.148 plus 0.2245 plus 0.2245 plus 0.2257 P4 0.1693 P5 0.1010 and P6 0.05. And 7 we have calculated it to be some value. P7 you can calculate. That calculated value, it works out to be 0.02. So try to observe. Now initially probability that getting a 0 defective is less. Try to think. Probability of getting 1, it is more probable that getting 0. It goes on rising up to what? 2245, 225, and then again it decreases. That is what you can say. This is probability of getting 0. This is probability of getting 1 defective. This is probability of getting 2 defective. Probability of getting 3 defectives. It increases a particular value. Afterwards, it starts decreasing. That is why the average value here, you can get it in the middle. That is approximately equal to 3. Probability that 3 defectives. That is also, it proves that. That is how it behaves. And beyond this one, it goes on decreasing these probabilities. This example I have taken so that I can teach you the probability of this binomial distribution as well. That is what it is happening. Okay. So these things can be calculated. How much time it will take, you just see. And this one, total 1 minus of, if you add up all these things, 0.9671 it will become. So this one, probability that is greater than or equal to 7, it gives me the value of 0.0329. Okay, this is the thing. If I calculate it by using the binomial distribution. Okay, let me see if I calculate it by the Poisson distribution, how much it gives me. Approximation. It may not give exactly like that one, but to the significant digits it will give. Not much I can tell you. And how much faster it is. And in the process, I will teach you also how you can refer the Poisson table as well. We know already you have learned about how to refer the normal table, standard normal table. With this example, I will teach you also how do we refer the Poisson table as well. Okay, shall I wipe out this one? Now try to understand now what is required. What I said, why I will be approximating it by Poisson's distribution, because P tends to 0 and N tends to infinity, and the product of N and P, it is a finite value, that NP is equal to 3. Okay. If I refer this binomial table, now what are the things I need to find out? What it says exactly, what is the probability that X will take a particular value, 7 is equal to what? Exactly. So you can go for the Poisson, this distribution itself, and substitute the values and find out. Instead of that one, we will try to make use of the Poisson table. Now, if you refer the Poisson table, it shows that the average value, that is NP or the lambda. This one we call it as table G. This is table G. Here, if you observe, C prime or NP are given in one column, and 0, 1, 2, 3, 4, that is C values. This one, the first column, it is the average value of C prime or NP prime. And along this one, it gives horizontal way, if you go, that is C value, that is 0 defective, 1 defective, 2, 3, 4, 5, like that. For example, if NP value is 0.3, in that case, two things we can draw upon here. If NP value is 0.3, then it may not contain more than 3 defectives. Try to understand. Because here he has given, he has stopped at here, because here 0.3, under probability that it contains 0 defective. That means having the average number of defectives to be 0.3, what is the probability that it contains 0 defective is 0.741 probability, or 74.1% probability. Probability that it contains 1 defective is 0.963. No, you are wrong. Because here under this one, these are the cumulative probabilities. Probability that it contains 0 defective, yes, because it cannot contain lesser than 0 defective, negative, no point at all. So it is 0.741. And under the column 1, it is probability that it contains 0 less than or equal to 1 defective. That means there are only two possibilities. Probability that it contains 0 defective and probability that it contains 1 defective. Okay, but it is cumulative, or 1, it is 0.963. That means it includes probability that it contains 0 defective. But if I am interested, that means here this 1 means it is less than or equal to 1. That is what it gives, not exactly equal to 1. Now you might ask me the question, how to calculate exactly 1. In that case, probability that it is less than or equal to 1 minus probability that it is equal to 0. That means that will give us the exact probability. That means for 0.3, it is probability that it contains exactly 1 defective is 0.963 minus 0.741. That difference will give you exactly like that, because these are